this week?
Both my history exams.
We have 2 chapters left in statistics to do. Well, it's not quite 2.
We have 2 chapters left?
Not quite. Definitely Z-scores.
Oh, that's not that hard though.
My last one is 18.
My last one is a 26.
I'm almost done, and I'm not going to go to school after that. I'm done with my last
So we have papers.
Okay, so.
Aye, aye.
Alright, so those of you that missed yesterday, what we did was we started just to look at a test. Because we had so much time together last week, the other classes did not. You guys finished your tests in that one day. Things were like, so I was like, let's just start a test and figure out what we know, what we don't know. And to me, it's been quite beneficial because I think you would agree, so far the first 4 to 5 and the first 5 part I, we have felt quite comfortable with what the questions are asking, and bless you, and it's a really recent test, so it's not like it's one that you don't quite, it's a harder test than it should be, because this is kind of where they're at as far as complexity. Yes?
You know what I've noticed? It seems that the May-June tests are easier than the October-November tests.
Yeah, and the grading is a little different as well. The May-June ones are given to a larger group of people.
Okay.
So when grading them, when grading them, if you think of it this way, if I have 1 million to grade in May-June compared to, however much in October, November, because those are just retakes.
Yeah.
So the idea is you want the answers to kind of fall a little easier to grade, because they have so much to grade.
Moral of the story, make it the first time.
Try to do it the first time, right? Now, there's less people on that bell curve for October, November, so if you know what a bell curve does for us, it just says they want more people right in the middle. So their grades get skewed a little bit as well. It's just a little different as far as grading. Yes?
So you say for October, November, while the test might be harder, they're going to get a curve.
It's a little different. It's not like a curve like we know here. It's, I want 20% of 1 million people, or I want 20% of
1,000.
Yeah, it's a little different, right? So, okay, so here we go. So yesterday what we did was we decided these are called optimization problems. We worked on them briefly before Christmas break, where you come up with 2 different equations. One is a full equation with a value at the end. One is a partial equation. We solve for the full equation, we plug it into the partial equation, and we make it look like they want us to make it look like. So we went through that process yesterday. Then the second part, inevitably, is, bless you, is for us to be able to show a max or a min and verify that it's a max or a min. Okay, so in this case, given that x and y can vary, find the dimensions of a sheet pen for which the value of A is a maximum. Anytime I see, find stationary points, find maximum, find minimum, tell me the nature of that. Anytime I see that, I should think I need to take a derivative.
Yeah.
I need to set it to 0. I need to solve for the variable that they're giving me. In this case, it's an x. I need to figure out whether it's a max or a min by using the second derivative test. So that's what I should think. But in this case, it said there is no need to verify that the value is a maximum. Okay, so we're good. Yeah. Why? Yeah.
You don't have to take the second derivative test.
We won't have to do the second derivative test. And if they give me that insight that I don't have to do it, if I do it, am I going to get it wrong? Probably. Wow.
They don't want you to do it.
They don't want you to go further. Right. So, given that x and y can vary, don't let that statement scare you. That just means that they can change whatever you plug it in. In other words, if x is 0, what's the area? 0.
Yeah. If
x is 1, what's the area? Well,
something else.
Whatever it is. If x is 2, what's the area? That's saying it can vary.
Yeah.
So the idea is which value of x is going to produce the biggest area that we're looking for. So if I take this area, and I think what we decided is even if I don't know how to do, even if I don't know how to do this, right, then what shall I do? Move to the second part and know that I'm going to take a first derivative, set it to 0, and solve.
Yeah.
Okay, so I can at least acquire 3 out of those points.
Uh-huh.
Because they're giving me what I need to utilize. Yes?
You just find a vertex?
You're basically finding a vertex, but you have to do it with a derivative. Okay? Because it's asking maximum. But how do you know it's a vertex? Because it's a squared. And which way is this guy opening?
Down.
It is opening down. So will you automatically know it's a maximum? Yeah, absolutely,
Yeah.
right? We see it. So if I take its first derivative, a prime, I got 384 minus 9.6 times 2x to the first. Okay? Notice I'm going to let you guys do the math. So we have 384 minus
19.2x. I already did part II.
19.2x.
Yeah.
Okay, and we're going to set that equal to 0.
Mm-hmm.
Because the steps to finding a max or a min is take the derivative, set it to 0, solve for x. So if I add 19.2x to the other side, okay, it doesn't scream I'm a trinomial factor me. It's a linear, so I want to bring one to one side and start to factor and divide or whatever.
X is
So
20.
19.2 goes into each side.
X is 20.
20.
Yep.
That's nice. It went in evenly. Yes.
Now plug x back into the original and solve for y.
Yeah, because it says given that find the dimensions, right? It says find the dimensions. When they say dimensions, when they say coordinates, when they say
Ordered pair.
ordered pair, you know that you need both x and y.
So if it's dimensions, would you say 20 by whatever y is?
Yeah, you're trying to look for that,
Okay.
right? 20 by whatever y is. Now go back into your former one. Was there any given place that was really easy to plug 20 in for x to solve for y? I remember there being one that was really easy. What was the perimeter again?
12x plus 10y equals 480.
And we actually did a place where we solved for y in terms of x, I believe, right? Wasn't there a place where we actually had y is equal to 480 minus 12x divided by 10? So I think there was a place where we had y equals 48 minus 6/5 x, I think.
Yeah.
That would be the perfect spot. Because if I plug in 20, automatically I get the y value I'm looking for. Okay? So if I plug in 20 here, I've got 48 minus 6/5 times 20. 5 goes into 24 times. 4 times 6 is 24. 48 minus 24 is 24. So yeah.
So for your answer, would you have 20, comma 24 like in the ordered
Well,
pair
let's
format?
look. What is the exact question asking? Find the dimensions of each sheep pen. Yeah, so each sheep pen. So it's going to be 20 by 24. Now, the reason why I went back to kind of really emphasize what it's asking, what other things could it have asked me to find, given that we found x? The perimeter. It could ask me to find the actual values, right? Could it actually ask me to find the area itself? Yeah. So we have to be very cognizant of what the question is asking, making sure we understand exactly what it's asking. Because you all know how to find the perimeter. Does everybody understand what dimensions means? Those are the kind of things that we have to kind of think about.
Huh.
Okay? Are we good? So, 1 through 5. I think we tackled 1 through 5 and without a lot of reservation. Now there's 11 total problems, so let's see how the latter half of this goes. Okay. So the next one is part A and B. What do we know about something being a part A
They're
and
two
B?
separate entities altogether.
Two separates. They don't connect to each other. Like I and I, we would utilize the information back and forth between them. Notice we just took what we did in part I and you just used it to find the dimensions. Okay, so for this one, there are two different things happening here. So find the values of the constant m for which the line y equals mx is a tangent to the curve y equals 2x squared minus 4x plus 8. Now I sat and pondered this one yesterday for quite a while because I want you to be able to recognize something so very important that they don't come out and tell. But let everybody look before you say it because I know you guys know. But I want everybody else to kind of look at it and dissect that problem to say what's important without them really telling you what's important. So find the values of the constant m for which the line y equals mx is a tangent to the curve y equals 2x squared minus 4x plus 8. Now, tell me a little bit about what that question has in it that might be important. Okay,
The
Lance.
tangent to the curve.
So what does tangent mean,
It's
literally?
the opposite or perpendicular to any line that comes off.
Right, it's a line.
That hits
Original.
It's a line that hits the original. How many times?
One.
It's one time, right? One time. So that's
it's one
important,
point.
right? So can you visualize this with me for a minute? What does 2x squared minus 4x look like?
It's like this.
Okay, so it's a parabola, right? It opens up. So I've got this random parabola. It's not going to be a perfect one. But I've got a parabola that somewhere in space opens up, right?
Mm-hmm.
And find the values. Why the S at the end?
Because there's more than one.
There might be more than one. Okay. Of the constant where y equals mx is a tangent. What potentially could that look like? Something that's a tangent. Go ahead. I see you drawing it.
Isn't it just a straight line?
It's a straight line
Off of
that's off of it, right? Somewhere in space, right? So it's a straight line that could hit like right here, a straight line that goes off of it, right? Or a straight line that goes off of it here. Could it potentially be that one? I don't know. You know what I'm saying? It could be any of these lines that kind of go off of that. So evidently there are exactly two, maybe. We don't know that. It says values. Are they going to give me an infinite number? Most likely not, right? So find the values of the constant m for which this is a tangent to that curve. Okay. Now, what the heck do we do? Yes.
Take a derivative.
So if I take a derivative, what do I get?
You get 4x minus 4.
The slope
Okay.
to any tangent.
The slope to
Right.
any tangent. The slope to any tangent. So if I did that, I get 2x minus 4 is the slope of any tangent. The slope of this particular tangent is m. So I get 2x minus 4. It would be 4x minus 4, sorry. So 4x minus 4 would equal m. Yeah.
Take the derivative, set it to 0, solve for x, plug x back into the original and get your y. And then you can plug that in to y equals mx and solve for m.
So let's try it. Because I have a different way to do it. So I want to see if this works. So you're telling me y equals 2x squared minus 4x plus 8. So you got y prime, because the derivative of this is any slope of any tangent line, right?
Yeah.
Right.
So 4x minus 4. So that's the slope of any tangent line,
Which is m.
right? So we're going to call that what? We're going to set it equal to m. Okay. Now what?
Solve
Yeah?
solve for x in terms of m.
Okay. So solve for x in terms of m. Okay, I got that. So I get m divided by 4 plus 1. Okay.
Yep.
That's x.
And then did you plug that into y equals mx?
Plug it here.
Oh.
Yeah.
So you're saying plug in.
Do you do? Like, do you plug Y in?
So I'm going to plug in m over 4 plus 1 there.
Maybe.
Is that what you're saying?
Yeah.
Okay, so what does that do for us? So y equals m over 4 plus 1 times x. No, times m, right?
Times.
Yeah. The other way around. But
But you have M, right?
Well, that kind of goes right back.
Right.
See, it did say on the mark scheme you can use a derivative to do this. But in my perspective, there's an easier way.
Are we going to use your favorite formula? Just
That would be difficult. I thought about that one yesterday as well. I suppose I pondered this one for a long time. Because I really wanted to see what was the way that you guys might think about doing this one. It is worth 3 points, so it should be a little challenging. Okay. I'm going to go back to this. Find the values of the constant m for which this is a tangent to this curve.
Yes.
So what does the tangent mean? You guys kind of told me again. It means it hits where?
At one point.
At one point. So they actually intersect once, right? Only
Yes.
once. What was ways that we kind of work through a process when we know two lines hit once?
Set them equal to each other.
And do what with it?
Solve.
Yeah. Oh gosh. So you said set them equal to each other. So they're hitting once, only once. What if I told you they never hit?
Do you have to do the...
You'd use a discriminant, right?
Yeah.
What if I told you they hit more than once?
B squared minus 4ac is greater than 0.
Right. So what if I tell you they hit once?
B squared minus 4ac equals 0.
Okay, and what do we do normally? We take one of them and we set it equal to the other. And how do we attack it if we're going to use the discriminant? What would we do? Okay, so
Yeah.
get it all to one side. So I'm going to pair up the thing with x, that mx with the other x. Okay? So far so good. So we're going to use, you said, because it's a tangent line and it hits only once, that b squared minus 4ac is equal to 0. So what's a?
2.
So a is 2, b, okay, and then c.
8.
Okay, is everybody in agreement? Okay. So let's see what happens here. B squared, so negative 4 minus m squared minus 4 times a times c equals 0. Now what?
Foil.
Okay, that's a hard one to foil. I have to write it out. My preference is to see it looking like that. Yes, Jade.
So if it's greater than 0, it hits twice.
Yeah. So I get what? 16 positive, and then positive 4m plus 4m, right? So plus 8m
Plus m squared.
plus m squared minus what? 64 plus you is 0.
16 minus 64
Is what?
is negative 48.
Okay. Oh, this might perhaps give me values.
And then you just
Factor it. It
Yeah.
screams, I'm a trinomial, factor me. And what am I going to get?
Plus 12 and minus 4.
So plus 12 minus 4. So the values of m
negative 12.
and 4. There you are. That's it. Now, how in the world would that lead you to use b squared minus 4ac?
Mm.
No, it never did tell you,
No.
right? It never came right out and said, use a discriminant.
Find the value.
Find the values meant to, right?
And
And the word
it's a tangent line that goes once.
tangent line hits once. So you can use a derivative. I'm not really sure where you go with it to find your values of m.
Because we got stuck.
We got stuck. Yes.
Well, if you take the derivative and set it to 0 and solve for x, and then if you plug x back in there, you'll get y, right? And then you'll have an x and a y, and then you can solve for y equals mx. But you only get one value for m.
Exactly. So that's what I kept running into. So it was kind of a strange one. I think if I say so far in all we've done 5, now we're at 6a, this would probably have been the most difficult one we've attacked because I think it's not real clear as to what it wants you to do.
Right.
We have done b squared minus 4ac equals 0. We understand that process. We've actually solved like this an abundance of times. But the way the question was posed becomes really confusing. Yeah. Yes.
Can't you just take a derivative and you get 1 point?
We would like to call that. Actually, on the mark scheme, it does say something about if you took a derivative. So,
When in doubt, drive it out.
right. That's what we're calling it today. I like it.
Everything.
Drive it out. Okay, so 3 points. If I came to this problem on an exam and I was like, well, I really don't know what it's asking, I might move on to part B and work part B and then go to 7 and 8 and then come back to that. I won't sit on a question for 15 minutes going, I don't know how to do it. You don't have time for that. Move to the ones you know so you can pull the points and then come back. Yes?
So you can do the numbers like out of order?
No, they're giving you a booklet. Do not do them out of order.
Oh.
But they're giving you a booklet where question answers underneath. Questions, answers underneath. I mean, can you move forward and do a question? Sure. But you can't do number 7 and number 6's spot.
Oh.
Does that make sense?
Yeah.
It's a booklet. It actually has a place for every answer. Yes.
So you can't do 5, 7, 6?
Correct.
Do you have like room to work?
You have room in every booklet. Yeah, it's nice the way they set it up.
Is it lined?
No. I say no. I'm not sure. Last year, I think, was the first year they did it for just one test. And I never really paid attention. We've always had lined paper.
Why would they not make it mine?
They might, I don't know. We haven't, I mean, we'll know the day we open it.
Right.
The continuation books have lines, so maybe they do.
What comparing does that on non-lined paper?
Remember, you have to use pen as well.
What?
Yeah.
You can't use pencil?
No.
You can How are you going to use the one piece of paper they give you if you use a pen?
They give you
The idea, though, if you use a pen and you make a mistake, just put a little line through it and then move on, because that mistake might pull points. You see what I'm saying? Okay. All right. The function f is defined by x as an element of the reals. We're not going to let that scare us. What does that mean to me? That x is any element, any value that you can find. They're a real number. Okay. The function is given by f of x equals x squared plus ax plus b, right? And where numbers a and b are constants, the solutions to the equation are f of x equals 0, and where the solutions of the equation f of x equals 0 are x equals 1 and x equals 9. What the heck is that saying to me?
When you plug in
Y equals 0.
When you plug in,
When you plug in
0 for
when you plug in 1, you get a value of 0. When you plug in 9, you get a value of 0.
Yeah.
So does that make sense? These are just ordered pairs?
So
Yeah.
then would you
1, 0, 9, 0?
would you have the two equations and then like eliminate?
That's really all it is. We've done these over and over. So we have 1, 0 as an equation, 9, 0 as an equation. We plug in the 1 and 0 into the function. We plug in the 9 and 0 into the function, and we have two equations with two unknowns. Okay? So, bless you. No? 0 is equal to 1 squared plus a times 1 plus b. And then we have 0 equals 9 squared plus 9a plus b. On a personal level, I like to keep it clean, like a's and b's are positive as possible, so I'm going to say a plus b equals -1. I think you would agree. Clean it up quickly. And then I've got 9a plus b equals -81.
Do you want to?
Set it up.
What's that? Yeah. I think I would just put one on top of the other and subtract to get rid of b. You could solve for b and plug it in the other as substitution, whichever you like. So I'm just going to put a plus b equals -1 underneath it and subtract the whole thing down. So I would have 8a, these are gone, and then subtracting means I add that +1, so I would have -80. A is -10. Really easy. Plug it in and solve for b. B is 9. Find the values of a and b. 2 points. Really, that's not bad. Yes.
When you say they say to write it in pen, it never says anything on the front about pen.
You have to write out for all A's tests. You have to write them in pen.
I'm guaranteeing it.
So what happens if you write in pencil?
It's a marked on grade.
They track you down.
It won't scan properly because remember these are being sent to multiple graders throughout the world,
That's the only reason
and they
do it.
scan them. And when pencil is used, they're not. It doesn't scan, so
Okay.
you'll end up with a blank sheet or one that's not properly. You can't really see it. So they've decided pen is the best way to go. So when they start scanning them to people, then they have, yeah. Plus, there's no way that people can erase it and change it for you or anything like that. I mean, it's deterring a lot of issues. Yeah, question?
So even things you cross out 10-digit blanks.
One line. Okay, I made a mistake in here. I put a let's just pretend. I put a positive 3 by mistake. Oh, I know that's not right. One line. A plus B equals -1. Let's just say positive 3 or a -3 was proper, the right answer. They might utilize that. Yes.
And you can get all the extra continuation papers you want?
You're not going to need them, I promise. There's plenty of room. Yes.
So I did substitution when I filled in, I got like the opposite answers. Like I got A is
So,
because for zero I solved
so you're -1 minus A. So then you plug in -1 minus A here. So you have 9A plus -1 minus A. So 9A minus A is 8A minus 1. If I add 1, I get -80.
Oh wait, did I just not? Oh, I see what I did. I just forgot it.
Okay, okay. All right, so the next one. The coordinates of the vertex of y equals f of x. I love this problem because there's two ways that you can do this problem, and they're not telling you which way they need you to do it. So right now we know f of x is equal to, more specifically, what was a again?
So -10x plus 9.
Was it plus 9?
Yeah,
Plus 9. Yep.
So, two ways we can find the vertex of something.
Complete the square.
We can complete the square. Very simple way is to complete the square. We'll do that. What's another way?
Take the derivative, set it to 0, solve for x, plug x back in and get your y.
That's right.
Complete the square.
There's two ways to do it. You all know both ways, right? So if I took the derivative, f prime, I would have 2x minus 10, 2x minus 10 set to 0, x is equal to 5. I would take 5, I would plug it back in here. So I would have 5 squared minus 10 times 5 plus 9. So 25 minus 50 is -25 plus 9, -16. Right? So my ordered pair, I think my math is right.
Yeah, I completed the square on that.
So when you complete the square, just to remind ourselves, step 1, bring the 9 over to the other side. Notice there's nothing in front of x squared, so we're good to go. Take b, divide it by 2, square it, add it to both sides.
But are we really adding it to both sides?
But are we really? Well, yes, because there's nothing out front other than a 1. And over here we've got a perfect square, x minus 5 squared. And over here we have 16, and we're going to bring it back over, so minus 16. And the ordered pair would be 5, -16. Two ways to accomplish the same thing. They didn't say, show that f of x equals a parentheses x plus b, whatever. You know how that works. What happened? It fell asleep that quickly. Interesting. Okay. Are we cool with those 2 points? I like that problem a lot. I don't like the first one as much. And you know, people will come out and go, that was the hardest test. And they did last year. And right now I'm thinking the first 5 were pretty much easy. Number 6 might have been a challenge, but number 6A will resonate in their head all day long because they were not sure what the question was asking. So that's kind of why it comes out as, that was the hardest test. Oh, I'm hoping that this year you guys have a little bit more confidence than every other class I've taught. We'll see how that goes. Okay, what's the next one? In the diagram, AOB is a quarter circle with center 0, radius r. The point C lies on the arc AB. Okay. And the point D lies on OB.
Uh-huh.
Okay, the line CD is parallel to AO. Parallel does what for us?
Parallel.
Same slope.
Same slope. Okay.
Same slope.
Maybe that'll matter. Okay. And then it says the line CD is parallel to AO and the angle AOC is theta.
Angle
Express the perimeter of the shaded region in terms of r, theta, and pi. Oh boy. Okay, so first of all, what is that ugly full thing? It's a quarter
of a circle.
Right? So
What are you talking about?
it says here, AOB.
It's a quarter circle.
AOB
Oh,
is a
alright.
quarter circle.
Looks
It's
weird,
really
that
funky,
picture.
right?
Okay.
Okay, so it wants me to express the perimeter of just the shaded region. Okay, so it's just the tippy top of that quarter circle. Let's talk a little bit about the shapes that we see here, just for the fun of it. Yes. What's this shape here?
There's a sector.
That's the circle sector, right? That's the piece of pizza?
Yeah.
You guys remember that?
Mm-hmm.
Okay, and what's this?
Triangle.
A triangle, right?
Yeah.
If you include the shaded thing, there's
And-
Yeah.
Yeah. What do we?
So can we think of the whole thing as one sector circle, and then find,
Like subtracted.
yeah, and then.
Well, it's not. It's a quarter of a circle, right? Do you agree?
So you divide it by 4.
So what do we have to find here?
The perimeter.
We have to just break it down into the 3 different areas.
So, do you agree if I find the perimeter? Is it perimeter?
Yeah,
The perimeter
if
of
I
the
find the
yeah.
perimeter of the whole,
that doesn't really.
that doesn't help.
No.
Well, yes. it
Yeah,
does.
you could find the perimeter of the whole thing and then find the perimeter of CAOD or whatever and then subtract.
But then it's,
Yeah.
at that point, it's just easier to find the perimeter of them individually.
Right, of every piece.
Yeah.
Mhm.
It says in terms of r, theta, and pi. So you don't need to know what r and theta are.
We don't.
So you just use an expression for each one.
Right.
So for like CB, what's that?
CB.
Just pi or r,
R 90 degree.
is that just r theta?
R
But in
90
this
minus
case, it's 90 minus theta.
Okay. COR
Am I guaranteeing that CD and BD are the same
or
size?
AO.
Is it a circular sector? I mean,
No, of the down to O. From OCB is a sector.
OCB.
And yeah,
a
that's a
sector.
sector. And CB is the outside of the sector. So if you use the formula for the length of the outside of the sector, which is r theta, right? So you know r is r in this case.
How do we know that?
Because the whole thing's a quarter circle, and the line CO is r, and we know that BO is r,
Mm-hmm.
because it's a quarter circle. So we know that it's
Okay,
Yeah.
so let's talk about that out loud.
2 sectors put together.
So here's the middle of the circle,
Right.
yeah? So from here to here, which is the edge of the circle, it's R.
Right.
Uh huh.
From here to here, which is the edge of the circle, it's also R.
Right.
Right? Does that make sense?
Right.
Okay? So here to here, R. Here to here,
Right.
R. Okay? This is theta.
So 90
This
minus
is 90, also known as pi over 2, because it wants to be in terms of pi.
Right.
Right?
Radians.
So, right. So what is this angle?
It's gonna be
Minus radius.
Which
Pi
is
over
pi
2
over 2
minus theta.
minus theta.
Pi over
So
2 minus
here's
theta.
what I'm going to do. I'm going to write on here.
That
Which is
is
what
the-
I
The most
suggested.
inconvenient board ever.
No.
So, it's awful, isn't it?
So,
If you just had one continuous thing, that'd be so
It would be so much easier. So this is pi over 2 minus theta. You
Right.
guys, this is theta, this is r, that's r. This is r. Are we good so far? Now, knowing what we know, there's two formulas for the area of the circular sector and also the
sector length.
crust, right?
Arc length.
The arc length. Do you guys remember that?
Yes.
S equals,
S equals 1/2 r squared theta.
that's the area.
And then it's just
R
theta.
R theta. It's in your bright colored sheet of paper, so therefore it's given to you, I believe.
I think so.
So, the pizza crust, this pizza crust right here, right,
Mm-hmm.
is S equals R theta. So what is R?
R.
R. What's theta?
Pi over 2 minus theta.
What we just found is this. Because we're looking for a perimeter, correct? So we're good so far there.
And then can you do like R minus something?
Distribute it.
Yeah, we can do that later.
So we now need to find this length. I'll do it in red until we find it. We need to find this length.
Yeah.
We also need to find this length.
Mm-hmm.
Yes?
Wouldn't angle C be theta or radius?
What would angle C be? Talk to me, yeah. Okay, what?
OCD?
You're saying
Yeah, OCD.
OCD
Would be theta or radius.
Yeah.
would be theta.
Yeah.
Tell me why.
Because there's the, I don't know what.
Parallel?
Transverse.
I don't know
These
what
are-
it's called, but
Because these are parallel,
yeah,
Inverse angles.
they're parallel.
and this goes through it. So if this is theta, that's also theta. Okay, cool. So this is theta. Nice.
Oh, transversal.
I think that's what it
Isn't there
is.
something like that?
Some weird angle law.
So now you have theta.
Well, then now you can find
We need to find CD.
I know how to find it.
really.
Nanny, nanny, boo boo. I don't know.
With sine cosine thing.
Yes.
Alright.
Yeah, obvious.
I was gonna
Like, that's
say,
obvious.
I think we're gonna have to use sine cosine thing to try this.
There's no doubt. So let's look. If I know the hypotenuse,
Cosine.
agree?
Is R.
Hypotenuse, right?
Yeah.
And I know this angle. Would you agree?
Yes.
So what is this, the red dotted line according to that? This is the
Opposite over hypotenuse.
over
The
hypotenuse.
sine.
Wait, what? Why don't we use theta? It's cleaner.
Okay.
That way we'll use cosine theta.
So we can use that. That's fine. Either way it would work. That's cleaner, you're right. So here is theta, right? So this is the adjacent over hypotenuse.
The cosine.
So the cosine of theta is equal to,
We don't know.
we don't know, over, we'll call it proper name, CD, right? Over R.
There's so
There's so many unknowns.
So it told us it's going to be.
Yeah.
It told us the answer is going to be ugly.
So just solve for CD.
So CD is equal to R cosine theta. So I'm going to add R cosine theta to CD.
and you also need to do
I also need to find
BD.
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 Can you do
Oh, now we use sine, what's it called? Sine of theta, and then we're going to get DO, and then we can take R minus DO to get
So-
BD.
Yeah.
You're gonna find this side. You're gonna take R minus this side to give us this.
So we can do sine
Exactly
of
right. So for this side, right, it's going to be the opposite or hypotenuse. So sine of theta is equal to DO over R. R sine theta equals DO.
and so BD would be R minus R sine theta.
Right, because BO minus DO equals BD, right? BO is R minus DO, R sine theta, gives me what we're looking for. So plus R minus R sine theta. Ugly, 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 but guess what? Perfect.
That's done.
Can we factor out R out of everything?
Can we just take a
There's no
group
need to, I don't
Cambridge
think,
test?
but it's fine.
What's that?
Can we just take a group Cambridge test?
Wouldn't that be nice?
I wish.
You can. You don't have to though.
I was gonna say just.
I
just
probably wouldn't. So perimeter. Now, because it's an I and an I venture to guess we're utilizing what we just found.
Oh, it's so ugly though.
Probably.
It says for the case where R is 5 and theta is 0.6, find the area of the shaded region.
I mean, just plug it in. That's.
So we have to plug them in. What is the area of the shaded region, by the way?
1/2 r squared theta.
Minus.
Because it's a piece of pizza in itself.
Yeah.
Well,
It's
Do we have to memorize that?
Oh.
'Cause I didn't know that.
this case.
It's on your break, what you
Whatever.
Yeah.
It'd be 1/2 r squared theta would be the area of the piece of pizza for COB, and then you do that minus 1/2 base times height, since that's a triangle.
Yeah.
Probably what you need to do.
Yeah.
Because
You don't use the perimeter.
this right here, these two are not the same size, therefore it's not a piece of pizza. It's one that I would eat, but not one that you. Right, right. So what we're going to do is we're going to use this, what we know as our piece of pizza, right, and subtract this beautiful right triangle from it, and then we'll get that. Are we with it? Are we together? So how do we find the area of a piece of pizza? Well, 1/2 r squared theta, right? And then minus, what's the area of this triangle? It's 1/2 base times height, right? Would you agree base and height are these two guys?
Yeah.
So it's 1/2 base, what was this line here?
CD, r cosine theta.
CD is r cosine theta. And then what's the height of it?
R, or
DO,
DO, which is
r sine theta.
r sine.
So let's see if we did that right. Let's see if that's all what we think it is. So it's the piece of pizza minus the right triangle, right?
So we just plug in.
Don't we have to
5.6
put
now?
pi over 2 minus theta and r theta? If we're trying to find that piece of pizza, don't we have to put pi over 2 minus theta in?
Oh yeah.
Yeah, you're probably right. Lance, way to be a buzzkill.
Or
All right, let's go back and look. So rather than, so
you could have left.
we could have left that part. So it's
Since they
1/2
gave us a theta,
r squared theta.
We have to make r
In this
theta.
case, theta is.
Right.
They gave us a set theta to begin.
And then we're back to what we had there. But you're absolutely right.
I thought you said they didn't remember.
Just for the piece of pizza.
And then we plug in r and theta and find.
So if you would agree with me right now, up until now, every single problem that we've seen or attacked with this type of thing here have been fairly easy. Would you agree? I mean, to me this is a lot more difficult than the ones that we've gone through. A lot more thinking process with it.
And then the only reason, like what we used R and I, was just to not have to worry about like the R cosine.
Right.
And R sine.
Right. What mode should my calculator be in?
Radians.
One half R. Wow. Yeah, you really ought to use calculator for that one.
Do they want a decimal?
It doesn't
You don't
say,
need the pi.
because they give you theta as a 0.6, I'm going to tell you to do decimals. Yeah.
Would you get any kind of points if you do it in degrees and you forget to put it in radians?
Probably not, because it did say for part I.
And it says AOC is theta radians in the
Theta radians, so no, unfortunately.
But if you got to this point and then put the answer into equation, so you get all the previous points, right?
Okay. Is anybody getting any answers? I would have thought that would have been on the difficulty level, a more challenging one. And again, it's a total of 7 points, so that's a large sum.
How many points was this total?
7 total. This part was 3.
I feel like I'm not right.
Because you would have done all the work in the first part to get the 2 sides.
642. Negative 6.642. What page is it? No, I figured it.
If it says radians.
You see a pi?
It has to be
You see
positive.
the word radian.
I don't get it.
What's the answer?
What's the answer? Yeah.
Did you get .488?
Oh my god.
That's not what I got.
.488?
I didn't finish. I'm gonna finish it tomorrow.
Oh, wait. Actually, I know what I did wrong.
6.31. 1/2.
Wait, I totally see what I did.
Quarter circle, minus triangle, minus second.
Miss K, can I want to put up in here?
You're closer than everyone else.
What was it?
6.31.
I got 6.29.